An automobile accident occurred at the intersection of Elwood and Austin Street in Jewell, New Jersey, between a compact car driven by Mr. C and a tractor trailer driven by Miss Lang. At this intersection, the truck driver had a flashing yellow light, while the car driver had a flashing red light. Neither driver claims responsibility for the accident. The car driver, Mr. C, claims to have made a full stop at the light before entering the intersection, that Miss Lang did not slow down prior to the collision. The truck driver, Miss Lang, claims to have been braking before the collision, that Mr. C did not stop at the flashing red light.
The police department determined that the force required to drag a 130 Newton car tire across the pavement at a constant velocity is 100 newtons. Specifications from the truck's manufacturer claim that, for technical reasons, the effective coefficient of friction for truck tires is only 70% that of car tires. After collision, the truck and car skidded at the angle shown in the attached diagram. The car skidded a distance of 8.2 meters before stopping, while the truck skidded 11 meters before stopping. The weight of the car is 13,600 newtons, and the weight of the truck is 69,700 newtons. The pre-crash angle between the velocities of the truck and car was 90 degrees. The truck driver claims to have begun braking in anticipation of a collision, traveling at only 6.7 meters per second at the moment of impact. Police measurements show that the distance from the car from the traffic light to the collision point was 13 meters. Ford Motor Corporation specifications indicate that the maximum acceleration of a comparably loaded Ford Escort is about 3 meters per second squared.
We can see that the car is moving only in the Y direction, and that the truck is moving only in the X direction. And what we gathered from crash details is that the car's weight is 13,600 newtons. The force of friction of the car tires is 100 newtons, and the weight of the car tires is 130 newtons. And for the truck, we gathered that the weight of the truck is 69,700 newtons, and the coefficient of friction of the truck tires is 70% that of the car. What we gathered from the crash details is that the car skidded 8.2 meters from point of collision at an angle of 33 degrees. So right here is a 33 degree angle. And that the truck skidded 11 meters at 7 degrees. So right here is a 7 degree angle.
The equations used to figure out who was at fault were the frictional force equation, F-net equation, free body diagram, velocity after collision, velocity in the Y direction, velocity in the X direction, and the final velocity equation. So to get the mass of the car, all we had to do was divide its weight by 9.8, and then we got this number. And we did the same thing for the truck. Now to find out the mu of the car tires, we just divided the frictional force by the Fn to get the mu, and then we inserted the mu into the coefficient of friction for the t, and then we got the coefficient of t. And then the acceleration, we plugged in the frictional force, which was 100, divided by the mass of the tire, which we had to divide by 9.8, and then we got the acceleration. And then for the acceleration of the truck, we knew that the mass times acceleration is equal to the F-net. And based on this free body diagram, the Fn and Ft cancel, and you're left with the frictional force. And so frictional force is equal to the mass times acceleration. And as you know, that the frictional force is equal to the mu times Fn. And then you get this answer. Okay, to solve for the final velocity after the collision for both the truck and the car, use this equation. So all you have to do is plug in your adequate data, and you should get the final velocity of the car in the Y direction is this. Now plug in your adequate data for the truck in the same equation, and you should get this. Now to solve for the velocity in the Y, use this equation, and then plug in everything that you know, and leave the VIYC empty, and you should get this. Then to solve for the velocity in the X, use this equation, plug in your adequate data, and you should get this as your initial velocity for the truck.
This equation is used to see whether the car is at fault. So you manipulate the equation to get the A by itself and plug in the data given. The acceleration ended up being 6.3 meters per second squared. So these are the final answers that you should get for the car. These are the final answers that you should get for the truck. They are both guilty because the car claimed to have stopped at the stoplight, but did not, and the truck claimed to be going only 6.7 meters per second, but was going 12.85 meters per second.